the video solution of exam 10. It's a prototype. Oh, before starting, I warn you that if you are not studied, or if you have not tried to do the exam alone, watching this video is the best way to waste this resource. Okay. Then don't come to me asking, do you have other exams? No. Please, before study, try to do it alone, restudy, retry to do it alone, and then only finally watch the video how would I have done it. Okay, so let's start. First of all, you have to connect to UBZ01FST. Okay, so for example, I click on this PC, I digit // UBZ01FST if you are at university. If you are outside university or connected from your computer, maybe it's better if you add unibz.it. Okay, and I have to do it because I'm at home. Okay, courses, not exams, courses, exam colletti. You will find a long list of students. Search for yourself. This is me. Enter. And now copy on your desktop the files that you find, in this case only one. If your desktop is a mess, like mine, this is considered to be a mess. Imagine yours. I have built an appropriate directory to avoid losing my files, so I copy the files here. Yes. Okay, now I don't close this one, I keep it open, okay, and I work here. Let's see, usually I give you some minutes before the exam the database structure and the R file structure, so you can become familiar with them. Okay, and when you start working, you already know what you have in your hands. So, database, we have to open it. Okay, enable content. Okay, for field grade in table who passes what, set decimal digit to 0, default to 18, and required options. So, design view, grade, decimal digit, decimal digits. Decimal places, sorry. To 0. Default to 18. A required option. Come on. Locked. Yes. Okay. Nothing else? No. I have to save because I've done structural modification. Well, it doesn't matter. Even if you test with the new rules, it's not true that it takes a long time. Okay. Create query good professors that displays the name and surname of professor with average of the grades they give, sorted from highest to lowest. So create query wizard from professors, surname and name. A name and surname, but doesn't matter. Usually I don't care about the order. Okay, well, if you want to be precise, name and surname. Average of grades they give. So the grades are in who passes what. Okay, next, give it a name. Good professors. Oh, it's me. Okay, design view, grade, no, totals, grade, average, sorted by descending. Okay, should work. Let's see. Yes. Oh, as you can see, there are professors more evil than me. Okay. Save and close. Create report 1 showing year by year and then month by month the student with exam they passed. Okay. Well, if you want, you can build a query to get year amount. I would suggest you to do it. So create query wizard. So students we need, so first name and last name, it's enough. Unfortunately, while I'm recording the video, Access regularly stacks and gets stuck for some seconds, like now. Okay, first name, last name. Okay. The exam paste. So from exam name. Okay. I have to get. Well, let's do it later. This is just a query. I don't give a name to this query. I leave student's query. I have to get, however, that from date, year, and so exam year colon year from of date. Okay, and here similar but with mount. Okay. We have everything. Yes. So I can save the query and now I build a report based on this query. Where is the report wizard? Here, based on query student's query. Take everything. Well, exam date, maybe exam name, exam year, exam mount, last name. Yes. Next. I want to group year by year and then mount by mount. No. I can't group year by year. By student, by who passes what, and by exams. Let's see, let's do it like this. Okay. Year. My axes are stuck as usual. Okay, exam year, exam month, fine. Okay, sorted by anything? No. Name, report 1. Finish. That's it. Year. Yes, it works. Okay. Build a query how many courses to list all the professors with a number of courses they have, including, however, also the professor without a course. So create query wizard. Where is the query wizard? I need professors, name and surname. Only surname. And the courses they have, so from exams, ID, no, how many? So I can count ID, for example. So I will take ID. The query name will be how many courses. Finish. Okay. I have now to count. Wait. So I have to count. Okay. However, if you stop here, you will not see professors without any course. In order to see them, you will have to set this relation here to include all the professors and only those records from who teaches what, where the joining fields are equal. Let's see whether it works. No, it doesn't work because you have to do the same thing here. Okay. And you see other professors such as Bach, Giacomo. Okay. Now I have to save, but my axes are stuck. Okay. Create a query on laude, which gives the laude to all the grade 30. Do not run it, obviously. Create. Well, let's start with query wizard. However, we just need who passes what. We just need the grade and laude. Next, next, or laude. okay? Now we have to convert it to update query. So grade criteria equal 30. Laude is updated to yes. Okay? Well, we don't have to run it, so I have to stop here and hope that it will work. Okay. Database is finished. I close it. Okay. I check that it's here. I close access. I don't copy files without closing access. Okay. Just to be sure, I will copy it on the network directory copy. Since I left my network directory open and I didn't close it, now I can paste it here. Windows will ask me what I want to replace. Obviously, yes. Okay, be sure that you're copying from your desktop to your network directory and not vice versa. Okay. Now the second exercise. Using R commander and data from dataset salaries in package car. So sometimes I give you a dataset, other times I ask you to take it from inside R. Build a document containing an analysis on the issues written below. Okay, so I have to prepare a document, so I have to open Word. If you want to build a document using WordPad or whatever other thing, which however must be able to contain graphics, so not pure text, it's fine for you. If you look at the bottom, this must be saved as exam.docx or exam.doc. So I save it immediately, just to avoid problems. On my desktop, have exam.doc. Can you see that I see the extensions? If you don't see them, go back to the precourse. Okay. The document does not need to be well written, so I don't care that you just write it schematic, but the relevant R output is mandatory, so I want to see some R output. And can you see without unnecessary information? It means that you don't have to take everything and throw it inside, who cares? Okay? Short comments, statistical test hypotheses, and conclusions. Okay? So let's start R. So I have it somewhere. Let's find it. Okay, I start our commander. I change the working directory. Okay. Now I load the dataset salaries from package car. From package, I click 2 times, dataset salaries. Also here, usually I give you some minutes before the exam, this file here, in this case. So it's a help on dataset salary. It tells you what is salaries about. Since you are watching this video, you have done the exam at least 2 times, you have already seen it. Okay, because trying to do the exercise without this doesn't give you a good. So I give for granted that you know what is a rank, what is discipline, years since PhD, years service, sex, and salary. Okay. Okay. So use tools to check whether there are evident data mistakes. As I told you, to check whether there are evident data mistakes, well, if you're lazy, you just do like this. Active data set. Okay. Poof. And you see rank is divided between associate professor, assistant professor, associate professor, professor, fine. Discipline A and B. In B, years since PhD, it's instead a scale variable, minimum 1, max 56. Well, rather a lot 56. Consider that somebody gets a PhD not earlier than 24, the person is already 70, no, 80. It may be a mistake, but it's believable still, no? Years of services, 60 years of services, well, rather a lot, this one also. There are much more male, as it is typical, these are university professors. Salary between 57,000 to 231,000, well, pretty standard. Okay, now to show the professors that I really did it, Okay, I paste it here. Okay. It's get badly formatted. Whenever it's get badly formatted, a dirty trick is to use font Miriam Fixed. If you find another font, fine for you. But the only one I found was Miriam Fixed. Arial, but Miriam Fixed is the best one. You reduce the font size. Okay. Don't worry if I don't see it very well, but I will enlarge it by myself. Okay. And I write short comments. For example, years since PhD and years of service seem to have a large maximum, but it is still believable. Okay. You don't need to write in Miriam Fixed. You can write in more reasonable fonts. Now I save. You can see it's just schematic. I don't write an essay, but I write the important information. Okay, let's go on. If you want to build more detailed summarize numerical distributions for all the numerical variables. Mean, standard deviation, interquartile range, yes, fine. Okay. This in case you want to be more precise. Oh, I see here that Miriam Fix doesn't work very well. And for the other variables, frequency distribution for the others. You don't click on chi-square because this has nothing to do with chi-square. I will consider it as a mistake if you click on chi-square. Also the percentages were not necessary, so let's redo it without the percentages. Percentages are mandatory. Okay, percentages are mandatory. We take the percentages. So we have discipline, rank. After all, honestly, the first one, maybe it's the easiest one. The easiest and the one which gives more readable result. And sex. Okay. So I will now remove it, however, since I have the first one, which honestly gives you really much better results. Okay. Save. Let's go on. Analyze numerically and graphically, use sample for rank, for sex, for years of service, and for salary. I repeat for to let you understand that analysis is done 4 times differently. So I don't ask you to analyze for rank and at the same time sex interconnected. No, it's 4 analysis different. When I write your sample, it means that you don't have to do any statistical test. So numerically and graphically, rank. Rank, you can see here, it's well, it's a nominal variable, so there are a few things to do. Graphs, first of all. Nominal variable, so bar chart. Also pie chart if you want. But since it contains, when it contains 2 things, if it contains, it contains 3 rank. So pie chart would have been also okay. Pie chart with 2 items, it's not okay. It's ridiculous. And then, well, the other one, we had it already, but let's redo it. Summaries, frequency. This was sex. Best. Had sex, rank. Here it's rank. Okay. Just a comment. There are much more prof than others. 67%. Okay. The others, sex, years of service, and salary. So sex, also here. Okay. Well, I don't ask you to to paint pink and light blue, but if you want to do it, it will be appreciated. Okay, and there are few women, 9.8%. Okay, years of service. Years of service different, obviously. Okay, you must use an histogram or a box plot. I will use the box plot. Median. Let's also the descriptive. I've forgotten. Median is approximately 18 and mean 17.6 with a long tail above. Okay, this one. Okay, and salary also. Same thing you do. Just to make a difference, I will use the histogram for salary. Salary. Okay. Here. Let's hope. How many? Well, nice histogram. And also the descriptive statistics. Op. Also here, long tail on the right. So you just write something to let me understand that you are understanding what you're doing, and then fine. Okay, that's gone. Analyze whether there is a relation between years of service, years since PhD, and years of service. So how do you analyze? First of all, you check your sample, for in this case with scatter plot and correlation, and then you do the test. You can do the test at the same time. Okay, let's see. Scatter plot. Years, what is? Years since PhD and years of service. Remove all the horrible things. Well, there seems to be a strong correlation. In particular, there seems to be a line here which is almost never passed. Well, it's obviously the line that you must have a PhD. Usually you are hired 1 year after PhD, so this is the reason of this line, which you don't find anything about this line. Well, let's write this comment here. Seems to be a linear relation, however, almost no case above the line because, well, look, if you have 20 years since PhD, you cannot be hired more than 20 years since PhD because almost nobody gets hired before PhD. Okay, let's do also the correlations. Where are the correlation? Where are the correlation? I don't know, don't remember. Correlation, metrics and test. Well, the test gives us also the value for the correlation, so we can use the test immediately. Pay attention because I don't want you to use the test when you don't have to, so when I'm talking about a sample. And second, if the test doesn't give you the information that I want, in this case the correlation number, I will mark it as a mistake. So let's ask for the test and Pearson, and I will make sure that, okay, can you see it gives me the correlation. I don't copy and paste everything randomly, but only the relevant things. So I copy and paste everything and then I delete the irrelevant things. So alternative hypothesis, confidence interval, okay. Okay, these are the relevant things. So Pearson correlation test. Okay, H0 hypothesis, correlation is 0. Okay, well, the interesting thing that I want is the p-value. Therefore, correlation is different from 0. Okay, let's do Spearman. Same thing, it's here. Take everything and then I delete the irrelevant things. Spearman's rank correlation raw. P-value very small. Sample estimate raw is okay. Also here I just copy. Op, correlation is 0. And the conclusion is the same. Well, with such a huge correlation, 0.90, sample correlation is very large, meaning a strong linear relation. 90% of variation of years of service is determined by variation of years of PhD. Obviously it's this one and not the vice versa, because first you do the PhD and then you do the service. Okay. Also here 90% of variation of order of years of service by variation of order of years of PhD. Okay, save. Analyze whether there is a relation between rank and salary. So rank, it's a nominal variable with 3 values. Salary is scale variable. So first of all, I will look at the means. At the means, I look where is it? Here. Numerical summary, salary summarized by group, rank. Okay. Let's write it in Miriam Fixed so I look at it better. So let's comment it out. There is a tab missing here. Okay. Averages seems to be different. Let's take a look with box plots also. Salary by rank. Oh. Distribution of profs is much larger. Okay. It's much more skewed on the right, as it is expected. And now I do the test. The test is the ANOVA, the parametric one. Statistics means one-way ANOVA. Yoo-hoo. Okay. Groups, rank, salary. Okay. We have already this data. Where is the... Okay. ANOVA test. H0 hypothesis, averages of assessed prof equal average. I don't copy and paste the H0 hypothesis which is in my slide, because I will consider you either lazy or you didn't understand anything, but I try to apply it to this case. Such proof. Okay. The statistics is the F statistics, but the only interesting thing for us is the p-value. P-value. Okay, which means H0 rejected. At least an average is different in this case, obviously, prof and maybe associ prof. Okay. Let's do the non-parametric test. Statistic non-parametric test is the two-sample Wilcoxon. Ah no, not two-sample, sorry. It's the Kruskal-Wallis. Rank, salary. Okay. Kruskal-Wallis sum rank test, H0, position of assessed prof salary is more or less the same as the position of assoc prof and the position of prof. Okay. Kruskal-Wallis chi-square, the value of, you can display or you cannot, doesn't matter, the value of the statistics and the degrees of freedom, in case you know what they are. The important thing is that you display the p-value, and you don't display anything else, extra information, silly things. H0 rejected. The positions are different. It was evident from box plot. Okay. Okay, save. Now describe the joint distribution of sex, discipline, and rank in the sample. Well, these are three nominal variables. If there were two, we would use the contingency table. There are three. There is the layered contingency table, something different to understand, but where is it? If I can find it. Contingency tables, two ways or multi-ways? Multi-ways. So, discipline, rank, sex. For the moment, no percentage. Well, no percentage because I just asked the joint distribution. If I were to ask the relation between you, I would have liked the appropriate row or column percentages. Here, okay. Well, it was not so big after all. So, let's call it contingency table. For sex equal female, the table is the following. For sex equal to male, the table is the following. Okay. What can you say from here? Well, 6, 5, 4, 6, 8, 10, 18, 38, 20. Oof. Well, the only thing I can say from here is there are more male assistant professor in discipline B than female. Because you can see here the assistant professor are more or less the same, A and B. Here there are much more. Okay. While for associate professor is more or less the same for us. Sorry, for professor more or less the same, for associate professor more or less the same. Okay, it's the only thing I can tell you. Can you see intersample, so you don't need any statistical test, and I don't want to see them. Now you need to study the relation between sex and salary. However, this relation is for sure influenced by the subject's rank. We have just proven it before. To remove the effect of rank building, a new scale variable, rank 2, equal to average salary for that rank, build a new scale variable, sorry, rank, build a new scale variable, rank 2 equal to average salary for that rank. For example, if the subject is associate professor, this variable must be blah blah blah. So first of all, we have to build a new variable called rank 2 equal to the average salary for that rank. So I imagine that you will rush here to data, or is compute new variable, but I tell you that it doesn't work. Also, record variable doesn't work. First of all, you have to know the averages of salaries. Well, okay, you can get them from here. Salaries by rank, do we have salaries by rank somewhere? We had them here. Okay, so I write them with my pencil 8776 93876 126772. Okay, and now I must do it compute new variable, record variable. Okay, I suggest you to use record. If you try to use compute, it will not work. You have much more difficulties. I don't know even how to do it. Rank 2, not a factor, assist prof equal 8776, assoc prof equal 93876, prof equal 126772. Okay, first of all I will check here, and then I will check in the dataset whether the variable has been correctly built. Don't give it for granted, Assistant, yes, can you see rank 2? Okay, let's write it here. Build rank 2. Well, it's not necessary, but just to remember, you don't need to pass the entire command, just how did you do? Okay, now build a salary 2. Salary 2 is equal to salary divided by rank 2. Okay, so in this way we get 1 if you earn exactly the average of your category. Okay, more than 1 if you earn more than what is your category, less than 1 if you earn less than what is your category. So salary 2 is equal simply by salary by rank 2 divided by rank 2. So this one you have to use compute. Expression to compute, salary divided by rank 2. The name of the variable, salary 2. Oh, done. Let's check because I don't trust myself. So 139 divided by 126 makes 1.10, yes. So makes sense. Okay, and now finally analyze whether there is a relation between sex and salary 2. If you did not manage to build variable salary 2, use variable salary instead. I will not be happy, but it's better than nothing. So now salary and sex and salary 2. So first of all, let's start with the graphs immediately. We need the sex and salary 2 box plot. Plot by sex, display salary 2. Okay. Oh, they are very similar. Can you see it this time? Rather similar, comma, male, more variation. These comments are necessary for me to understand whether you are understanding or acting mechanically. Okay. Because the female is slightly less than 1, male is slightly equal to more than 1, maybe at the median. My word are stuck. Okay. Okay. And now let's do the rest. Statistics, summaries, numerical summaries, summarized by sex. I want salary 2. Okay, let's put a tab here. Maybe I can fix it. Okay, can you see in fact the mean of female is slightly less. Mean of female slightly less. We have to check with the appropriate tests whether it's okay or not. Finally, let's do the test. So which test do we do? Independent samples test. Sex, salary. This is the student test. It calls Welch, but according to my opinion, it's students test. So students test for true. Population age 0 average salary true of male on population is equal to average salary true of female on the entire population. Oops. Okay, let's see. The statistics is negative, degrees of freedom, p-value 0.08. Slightly more than 5%, we have to accept. So even though somebody would reject with more than 5 but less than 10%, however, we have decided 5%, we have to accept. This means that in all data there is no evidence that on average male earn more than female compared to rank, because we have divided by rank. Okay. Non-parametric test. Two sample Wilcoxon test. Sex, salary true. Okay. This one you can call Wilcoxon or Mann-Whitney. I will call it Mann-Whitney. I give you the permission to call it Wilcoxon. The other one, please call it as it should. Okay, p-value 0.21, so we have forgotten H0. H0 distribution of salary true is same for male and female. We accept id est position could be the same. Okay, I save. Okay, I have to return the doc, the rdata, the r, and the txt. So I close it. I check it's here, xm.docx. So now I save my script here. Save script as this one on my desktop. xm.r. I save my output just to be sure. It's in xm.txt. And finally, I save also my workspace. Why do I need all these savings? Well, if you've done a perfect exam, I honestly don't need them. But since many of you don't do a perfect exam, sometimes I have to understand what you're doing, and I have to look at your data, at your output, at your script. That is the reason why I ask you to save everything. You will get extra 5 minutes to do this copying at the end of the exam. You check that everything is here. You don't reopen clicking randomly. If it is here, it is here. Okay. You close everything. You don't save anything else again. Okay. And now, since you were so smart to leave your network directory open, you take everything. Well, we have already copied this one, so we don't need, and copy them here. If you want to check whether it's copied or not, you don't reopen it from here, creating confusion. You just look at the date. Okay, your exam is finished.